Good morning, and welcome to today's webinar titled Variant Interpretation, Literature Curation, and Clinical Trials. Oh my! How to simplify somatic NGS analysis and reduce literature review time by 90% with HSMD. My name is Caitlin, and I will be the host and moderator for today's session, presented by LabRoots and brought to you by QIAGEN Digital Insights, or QDI, the bioinformatics business of QIAGEN and the leading provider of genomic and clinical knowledge, as well as analysis and interpretation tools and services for scientists and clinicians. For more information, please visit www.digitalinsights.qiagen.com. We'd like to extend a special welcome to the NSGC members who've joined us today. Thanks for filling our virtual seats, and we really hope to make this presentation particularly relevant for all of you today. Over the next hour, our speakers, Chelsea Alexander, Project Manager for the Professional Services Group at QDI and former Certified Genetic Counselor, and Aarthi Goverdhan, Lead Scientist for Oncology Application Development at QDI, will discuss current trends in somatic testing and the corresponding challenges faced by modern genetic counselors and clinical cancer professionals, focusing on a new tool designed to streamline, simplify, and shorten the life cycle of somatic NGS testing in light of these challenges. We encourage you to participate today by submitting any questions that you might have during the presentation. To do so, simply type them into the Ask a Question box and click Send. We'll answer as many questions as we have time for at the end of the presentation, and any questions that we don't get to, we'll follow up with via email, the email that you provided at registration. If needed, you may also submit any technical issues in the Ask a Question box as well, such as if you have any trouble seeing or hearing the presentation. One more thing before we begin, our legal disclaimer. QIAGEN products shown here are intended for molecular biology applications and not intended for the diagnosis, treatment, or prevention of a disease. For up-to-date licensing information or product-specific disclaimers, please see our website, www.qiagen.com. And with that, let's get started. Chelsea, why don't you begin by talking a bit about your experience as a genetic counselor? Maybe give us a breakdown of your day-to-day, how you spent your time, and the challenges that you faced.
Thanks, Caitlin, so much. Like anything, genetic counseling as a practice has continued to evolve and adapt to changing needs and influences, technology, as well as new knowledge. As many genetic counselors there can relate to, a lot of the activities that we do kind of on a day-to-day are directly outside of a patient-facing visit. Looking back at, I was a clinical genetic counselor for 8 years, and I've noticed that I think that there were phases where the time that I spent on specific activities and patient care related activities was particularly salient. And I'm going to break those down into 3 areas specifically. So one of the first transitions where the access to appropriate resources I think was critically helpful was the difference between grad school and moving to clinical genetic counseling practice. The amount of time spent on non-patient relating activities and transitioning to my first role I found a little bit surprising, as that's not something that necessarily all genetic counseling programs really delve into. And so that initial transition into clinical genetic counseling work, including EMR documentation or electronic medical record documentation, insurance authorization, information surrounding billing and coding, as well as care coordination, both with my, the other individuals in the multidisciplinary clinic that we worked with, as well as social workers or other things like that, or care providers, I saw as a really big transition. So, and that is in addition to the kind of patient-related activities such as researching results, literature review, as well as the time and effort going into patient care. So getting up to speed with all of the non-schools related aspects, being a healthcare provider, I felt kind of maybe a little underprepared as far as the resources available to me. The second time is transitioning to a new clinical specialty. So I have moved into different specialties throughout my clinical practice. And this, as many of my GC colleagues can probably attest to, comes with a new set of challenges. So getting up to date on the knowledge, the expertise, the background information, either starting a new clinical genetic counseling practice or establishing relationships with new care providers, all takes a lot of effort. And those new processes, getting up to patient care, and also knowing what resources are available in those phases. It comes with new challenges, and searching for resources in genetic testing that's appropriate, as well as understanding the processes as well. And then the last part that I think is particularly relevant, especially for current day and age, is when there's a technology shift. So technology and navigating the new transition when new testing or results or genes are added or new panels, specifically with the items task like literature review, can be really daunting to patient care, I think. And so versioning technology right now, moving into the kind of somatic space, I think I see that as a technology shift in something where additional resources can be really helpful. To further this point, some of the historical shifts for genetic counseling and success have been written by some of our colleagues. I'll point you to an article by Bob Resta from 2019 as far as a history of measuring the success of genetic counseling, which I found particularly interesting. But he specifically talks about new testing technologies and how this kind of created a flurry of activity in the genetic counseling world. For example, when amniocentesis came out, maternal serum screening, we've seen different challenges, different transitions as well between now whole exome, non-invasive prenatal testing, as well as whole genome as well. And so the influences of these testing changes, technology changes, have influenced practice and what this looks like. So I think clinical genetic counselors who have been practicing for a little longer, the transition, even from what genetic counseling looked like and the resources available and what our day-to-day looks like, even from the early 2000s, has shifted dramatically. And we've been having to practice and adapting to these new technologies, the new kind of scope of practice and what we're supposed to do in these transitions. And a lot of us do remember the transition from microarray to NGS to whole genome and exome. And now recently that has kind of spanned into the somatic NGS space as well with somatic testing. And so with this notable shift in tumor testing and genetic counselors' involvement in somatic variant interpretation and transition to patient care, this is where HSND could come into play.
Yeah, definitely. First of all, thank you, Chelsea. It's really interesting to learn more about the rich history of the genetic counseling profession and the challenges faced by GCs. I've been working in the precision oncology space for several years, and to some extent, I have witnessed the evolution of the space when it comes to how tumor genomic profiling is more broadly adopted now compared to several years ago. More institutions are performing tumor genomic profiling using commercial panels or customizing and creating their own NGS panels. And even commercial NGS panels are getting larger with more and more genes being interrogated, more variants to detect. So I think we live in a really exciting age with these new technologies supporting more treatment options for cancer patients. Coming back to your experience as a GC, I've had the privilege of collaborating with some amazing GCs like you who are working on variant interpretation. They're really passionate about helping patients. And I did want to know more about how much time do GCs spend typically on one patient? When it comes to research and reviewing literature, reviewing testing results for a patient, and so on and so forth. If you could ballpark that, I'd like to know more.
Thank you, Aarthi. I appreciate the question. There has been particular effort to outline genetic counseling workflow and time studies, and I am going to reference one of the recent ones in a paper by Courtney Attard et al. In 2019 in the Journal of Genetic Counseling. They looked at genetic counseling workflow specifically. And I'm sure a lot of other individuals have the same experience where personally I've worked at institutions where we've had to do time studies to garner support for additional genetic counselors or FTE or things like that to kind of know what we were spending our time on. So particularly in those in previous studies, 3 hours of patient-related activities were performed. And less than that, less than 1 hour was spent in face-to-face time with patients. It is often this kind of unseen work that I think can be really challenging from a genetic counseling, just because it's not seen kind of to other providers or our patients, even as far as the amount of work that goes in both prepping for a patient visit as well as kind of coordinating what needs to be happened after. So in particular, there have been time studies for genetic counseling services, even back through the 80s and 90s and early 2000s as well. So they have shown that often there's about 7 hours per new patient and 3.5 hours for returning patients spent on these non-patient facing related activities. And that was a study by Bernard et al. In 1987. I think specifically some of the kind of hidden work or this additional challenges that face genetic counselors is navigating all of the kind of downstream impact that happens after seeing a patient. And I think there's other evidence to support that, specifically in the somatic realm, and burgeoning somatic tumor testing as well, that it is taking a lot of time and effort for genetic counselors to do. For example, the NSGC has the development of a cancer special interest group pilot for on-demand case review services through the NSGC, which I think is an amazing service. A lot of institutions or places of practice might have their own tumor boards for patient case review and things like that. And so you're putting a lot of really smart people together to think about the best way to treat a patient and what makes the most sense. And all of that takes time and effort. And so it's clear that individuals who are providing genetic counseling, especially in this context, need as much information as possible, and that resources are being actively developed to support them. And so HSMD could possibly help with that.
Yeah, definitely, Chelsea. What HSMD does best is provide expert curated information for somatic cancer variants, hence the name Human Somatic Mutation Database. HSMD contains more than 300,000 clinically observed variants in cancer that were manually interpreted by our team of precision oncology scientists. And in addition, it contains several 100,000 more variants that were manually curated from the literature, and also contains drug approvals, oncology practice guidelines, and clinical trials. I'll point you to a case study. Dr. Anna Kravakica and her colleagues at the Institute for Oncology and Radiology of Serbia, they were one of the early adopters of HSMD, and they reported to us that they were able to substantially reduce the time that they spent on variant curation, and that's actually where the up to 90% reduction in literature review time in the webinar title comes from. So I encourage you to check out the case study, which I believe is linked in the resources section if you want to learn more. I'll sum it up by saying I think for lab GCs, HSMD can be really a very useful tool. It can help reduce curation time significantly. And similarly for clinical genetics professionals and clinical GCs, HSMD also has a lot of valuable resources. So I think it has something for each one of you, whether you are working in the lab or working more on the clinical side. So now I think is the perfect time for us to dive straight into HSMD and see a demo so that I can show you all the cool features. So yep, hold on. Let me share my screen. Okay. Welcome to Human Somatic Mutation Database.
Cool.
This is the HSMD landing page. And as you can see, there's a search bar here where you can search by gene, alteration, protein change or coding change, or even structural variants, and by drug, disease, or clinical trial. And down here, the numbers basically tell you how many genes, alterations, diseases, drugs, and trials are represented in HSMD as of this particular moment. If you go to an Explore page, you'll get high-level information about, for example, if you go to the Explore Genes page, it will tell you which genes are covered by HSMD and provide high-level information about the number of variants that are curated for a particular gene and the number of associated drugs and clinical trials and so on. So let's start by looking at the Explore Genes page. All right, so this is the Gene Explorer. As you can see, HSMD contains a large number of genes, more than 1,400. And on this page, we've provided some high-level information for each gene that is covered by HSMD to enable you to search, sort, and filter according to the information that's provided here. For example, the genes are classified as oncogenes or tumor suppressors. And if there's insufficient evidence to classify them as one or the other, then they are listed as not established. And similarly, you can search for genes that have at least one variant that falls into a specific category, like let's say with a functional impact of known inactivating. And you can search for genes that have at least one variant that is tier 1. So for this example, let's look at oncogenes. All right. So by default, it's sorted by the number of variants per gene, highest to lowest. And so EGFR is the one that has the highest number of variants curated. And yeah, there will be instances where genes are listed as both oncogene and tumor suppressor because they may be one or the other, depending on the context. And as you can see, there are a lot of these are well-known oncogenes. And for the sake of showing you an example, I am going to pick PIK3CA. Whenever you see that an entry is underlined and in blue, it means that it's hyperlinked to another page. So for example, clicking on PIK3CA here will take you to the gene page for PIK3CA. All right, so this is the PIK3CA gene page. Every gene page starts off with a description summarizing the role of a gene in cancer and its function. You also have external links to take you to other databases or resources if you want to check them out as well for a particular gene. And then you have these two sections, alteration type and functional impact, and actionability distribution will provide a breakdown of the number of alterations in this gene that are represented in HSMD, and basically categorizing them according to alteration type, the functional impact type, and actionability classification. So here, let me take a moment to tell you how we assess actionability. The actionability classification in HSMD is based on the 2017 AMP ASCO-CAP guidelines, and the actionability that you will see for a variant is the highest actionability across all cancer types. So we are well aware that labs will sometimes have their own protocols and their own classification systems. HSMD aims to provide the evidence that you need to arrive at a particular classification for a variant, but the actionability that we provide is just a guide based on the AMP guidelines. And I think the coolest graphs on this page are observed clinical case distribution and alteration distribution. The observed clinical case distribution graph presents data that was extracted from our real-world clinical oncology dataset. So remember I told you that our team of scientists have manually interpreted more than 300,000 clinically observed variants. So these variants were observed in clinical cases that were sent for interpretation to our professional interpretation service team, and represents a large number of real-world cancer patient samples. So what this graph shows is the mutational frequency of the gene in different cancer types as observed in our clinical dataset. So as you can see in the table, lobular breast adenocarcinoma is the cancer type which demonstrated the highest mutational frequency for PIK3CA. And if you hover over the bar for lobular breast adenocarcinoma in the graph that's shown next to it, you see that it shows you a functional impact breakdown. So for all the variants in PIK3CA that have been observed in lobular breast adenocarcinoma, it shows you how those variants were classified. So in this case, 48% of them were actually assessed to be known activating mutations in PIK3CA. And you can get similar information for other cancer types as well from the graph. The alteration distribution graph below it is also presenting data from our clinical data set. And what this is showing you is it's a lollipop graph presenting the frequency with which mutations at a particular codon of PIK3CA have been observed in clinical cases. So as you can see here, there are quite a few hotspots within PIK3CA where mutations are more frequent. And H1047 stands out. There's an E726, of course, E545, E542, and so on, N345. Okay, so as an example, let's click on this. Okay, so when you click on a lollipop corresponding to a particular codon, it navigates you to the alterations table and basically filters the table to show only those mutations that occur at the specific codon. Here you see there are a whole lot of different amino acid changes at N345 that have been clinically observed, are part of our data set. And okay, let's clear this search and look at all variants in PIK3CA. Tier 4, Tier 1, okay. So you can see that for the 6,000 alterations in PIK3CA that are in HSMD, there are the chromosome position, the genomic coordinates, coding change, protein change, and other information available for each one of them. I think the cool thing about the alterations table on the gene page is that you can also search for alterations in a specific genomic range. So for example, what shall we look at? Okay, for example, let's look at this, 88. To 118. Search. And then you can sort by position to see them in order. Yeah, there you go. So now it has filtered the list down further to show you only the mutations that occur within the range that you've entered in here. And that way, even if you're looking for a particular alteration and it doesn't happen to be in HSMD, you can look to see if there are any alterations at neighboring residues that have been reported before. So I think that's really cool. And oh yeah, one more thing I wanted to point out here is that you'll notice there are two different source types. We've already talked about clinically observed. It's a part of our clinical oncology dataset. QIAGEN KB means that even though this variant has not been reported in a clinical case as part of our dataset, it has, however, been reported in the literature, and our curators have essentially curated information from the literature for this variant. In some cases, you may have functional studies information available. In other cases, you may have some clinical case information available for those particular mutations. But QIAGEN KB basically indicates that there is at least one reference that mentions this particular mutation in the literature.
So Aarthi, one thing that I just want to call out in addition to the genetic testing results, which genetic counselors are going over either in a lab setting or a clinical setting as well, specifically to a clinical setting, the other relevant data that can be really pertinent and critical to patient care is often difficult to find or navigate resources that are currently available. And so one of those areas can be FDA drug approvals. So for our colleagues who work either in medical affairs in other institutions or individuals who are working in the clinical practice, tracking down information about new drug approvals, specifically for new indications or existing drugs that are being remarketed and targeted to a specific variant or mutation, it can be really challenging for what I have seen and what I have experienced. Having information within HSMD that is variant specific with that kind of information available seems like it could be really helpful.
Yeah, so right. So the two sections that I did not get to are drugs and clinical trials. So, okay, let me zoom in a little bit. So for example, right, I'm interested in PIK3CA mutations, and I see in the drug section, I can actually look for drugs that we know are associated with a sensitive response when a PIK3CA mutation or activating mutation is present. And so, for example, here, alpelisib is FDA approved, and well, it's FDA and EMA approved, but specifically, it is FDA approved for treatment of PIK3CA mutation positive breast cancer. So what you see here under specificity is the specific mutations that in PIK3CA that are detected by the companion diagnostic for alpelisib and So those mutations are listed here as conferring sensitivity to alpelisib fulvestrant and as part of the FDA approval. Additionally, you can also see, like, let's say we're talking about a gene that actually doesn't have any specific indications, any FDA approvals for that specific biomarker positive cancer. I think that's where specificity of targeted comes in handy, where we know that the drug in this case does target PIK3CA. It's one of the targets of alpelisib. Similarly, copanlisib is FDA approved in lymphoma, but not specifically in the context of PIK3CA mutation positive cancer, but it does target PIK3CA. And duvelisib also does target PIK3CA. So I think the drug section provides a lot of that additional information. Also, if you click on this link, it'll take you to the drug page for alpelisib fulvestrant. And essentially what the drug page shows you is at the top of the page, you have a summary of the FDA and EMA indications for the drug. And then below, you'll have a list of the biomarkers that are known to be associated with sensitivity or resistance to that particular drug. So I think that could be really useful. And what else? So PIK3CA, not a great example for resistance, but let's look at an ALK mutation, shall we? Okay, I'm going to use this search here and pull up an ALK mutation. Okay, ALK F1174L. This is the alteration page for this mutation, and as you can see, similar to the gene page, we have a description that our scientists have put together for this particular mutation after reviewing all the evidence that's available for it in the literature, in professional guidelines, drug approvals, and so on. And the description for ALK F1174L, specifies that it is known to be activating and have transforming activity from functional studies. And in addition, it calls out resistance to therapies like crizotinib and ceritinib. I think it can really be useful also to have this level of detail where the mutation is shown as being detected in a patient with a particular tumor type who developed resistance to crizotinib. And it also includes details about preclinical evidence for sensitivity or resistance to particular drugs. So I think that could be something that's really helpful as well. And similarly, the alteration page has this drugs table. You can just you can pick resistance as the response if you want to look particularly at drugs associated with a response of resistance for tumors harboring this mutation. And yeah, this is, in a nutshell, this is the sort of information you can get for drugs. And then, there is information for clinical trials as well.
That's great. Because in searching and finding for what is pertinent to your specific patient, as far as like open and recruiting clinical trials, eligibility on clinicaltrials.gov and other resources, I have found that incredibly challenging personally. And so having this information in a kind of collated format that has some link up to relevant information seems like it could be really, really helpful and useful to patients.
Yeah, and you see here in the clinical trials table, it lists the drugs that are being investigated for patients with an ALK mutation, the disease type, phase, and again, here, if you click on this, it's hyperlinked to a trial page for this specific trial. And, there are actually multiple ways to search for trials in HSMD. You can search through the clinical trial section on the alteration page and on, the gene page. But another way to do it is to use the Clinical Trial Explorer, and I'll tell you why I like this option. Because here, not only can you enter in a specific, trials, let's say recruiting patients for mutations in a specific gene, you can enter in the alteration as well, or search by specific drug. But one thing that I really love about the Trial Explorer is that it allows you to search for trials by country, by location, and radius. Okay, let's try out one example. I'm looking for a trial for a patient with an ARID 1A mutation. So I entered that into the gene. I'm going to say USA, United States, search by location. Okay, let's try Chicago. There we go, Chicago, Illinois. You can pick distance. I'm going to say 50 miles. Search. Oh, look at that. So we've pulled up 3 trials that are close to Chicago and recruiting patients with an ARID1A mutation. And so now let me click on this to show you what the trial page looks like. Yeah, so there's a description, there's a link out to the clinicaltrials.gov page for this trial. There's some trial details and location. Look, Chicago, Illinois. And you can look, scrolling below. It's recruiting patients with ARID1A mutation positive ovarian carcinoma, endometrial, urothelial, and broader solid tumors in general. So yeah, this is what you can do with the Clinical Trial Explorer in HSMD. So this next segment is for those of you who aren't completely focused on somatic variant interpretation. With the expansion of somatic NGS testing, most of the commercial labs are doing tumor-only testing. And there was an entire session at the Association for Molecular Pathology's annual meeting last year devoted to discussing the benefits of performing tumor normal paired sequencing, not simply just to subtract out germline variants, but also to perform a focused analysis of genes that are known to be associated with hereditary cancer predisposing syndromes. So we know that because most labs are performing tumor-only testing, a lot of times you may pick up presumed germline pathogenic variants in the somatic NGS test. So as GCs, how are you handling this? And would you say that there's a shift in the involvement of GCs throughout the tumor testing process, be it somatic, be it germline, just having someone speak to the patient, making it clear to them that even with tumor testing, they may potentially be notified of some sort of, some germline finding that could have implications, not only for their own treatment, but also for their family. So can you tell me more about how that the GC field is evolving in that area?
Yeah, thanks, Aarthi. So all genetic counselors in grad school and beyond learned about the possibility of somatic or germline mosaicism, and this can be relevant to any specialty or subspecialty. But related to NGS specifically with somatic testing and best practices, they are actively being defined. For example, the NSGC has a Lynch syndrome practice resource that was developed in January of 2022. And the authors, I think, particularly were very thoughtful about including information to consider to assist with this, navigating these new process and the possibility of these results, the complex results based for NSGC-based tumor profiling as it's becoming more and more common. So some of the things that they pointed out are, some variants identified on tumor genomic profiling, they actually may represent germline variants with clinically significant implications. So like you said, having information up front and genetic counselors involved prior to genetic testing in this somatic case, I think is incredibly important to be able to have that discussion with the patient, because it does have implications for their health as well as their family. Additionally, confirmatory genetic testing is then recommended for individuals who have tumor genomic profiling results that identify a pathogenic variant or likely pathogenic variant that is suspected to be germline. And we know that that information might not be the same coming from all labs. You might have different test results and different variant information. And so I think genetic counselors and providers need to think in the back of their head and be aware that not all commercial tumor genetic profiling tests or platforms are created equal. And I think
that's right. Yeah. That's a great point, because I'm not sure that all labs call out the possibility that a variant could be germline. So, it's really important to keep in mind that you might, you could assume it's a somatic variant because the lab hasn't called it out on their report, but it could very well be germline. I think that's part of the challenge when it comes to differentiating between somatic and germline variants. There was a time when variant allele frequencies that fall within the 40 to 60% range was used to differentiate the germline variants from somatic, but we know that that's not a perfect indicator either. I think there's still quite a bit of work to be done in terms of solidifying the best practices when it comes to reporting out variants from a test and being really transparent about the results and about what can and cannot be detected by a particular test, like somatic versus germline, and also what can and cannot be reported by a particular lab, depending on.
No, I totally agree. I think I totally agree. As genetic counselors, I think we're pretty well versed in making sure we pick the right test at the right lab for the right patient, but making sure that we know that not all tests are created equal. Not all labs might have the option for germline testing. And one thing that I thought was really powerful about HSMD when I was learning about it is that the information is lab agnostic. Is that right?
Yes, that's right. Our professional interpretation service team receives cases from labs all over the country. And as we've just talked about, most commercial labs are performing tumor-only testing. So we know that our team is interpreting a lot of somatic cancer variants, but also some potentially germline variants in genes that are associated with hereditary cancer predisposing syndromes. Now, HSMD is not an exhaustive resource for germline variants associated with cancer, but definitely combining HSMD with a well-established germline variant database like HGMD might be really useful for a genetic counselor to figure out if a variant that they came across in a patient's report is potentially germline or a somatic variant that's been reported before. So I think that's one way that HSMD could come in handy.
Yeah. And I think a lot of genetic counselors either watching or like myself remember relying really heavily on HGMD kind of in navigating the transition to clinical whole exome sequencing and having access to the most information as possible. So I can see a correlation with the HSMD. Because another challenge also relates to the classification of variants in a somatic testing situation, in that not all laboratories that are performing testing are going to call a variant in the same way. So the shift of how testing has been completed for patients, driven by obviously some of the lower cost of genetic testing capabilities, we're seeing the kind of burgeoning of like larger somatic genetic testing panels. And so you're testing people for a lot of information, potentially with a lot of variants, and not always knowing what to do with that information. And so counseling, I think, like you said before, after, and during the tumor testing process is something that's being recommended by a lot of the larger institutions like ASCO and stuff. And so creating awareness around the possibility of these incidental findings and the resources that are available to assist in these conversations, I think, is really critical. And so it seems like HSMD can help in this way.
Yeah. As you said, with large NGS panels, whole exome, whole genome, you are hit with more information than you know what to do with, and you find yourself wondering how to distill it down to its essence, to the clinically actionable, the clinically significant information that can help you find potential options for your patient. And that's what HSMD was built for. It was built to help and support labs and clinical professionals in their daily work. To your point about the difference in classification systems for somatic versus germline variants, there have been articles that also have reported that, yes, a lot of the times presumed germline pathogenic variants can get lost or buried in a long list of variants of uncertain significance on a somatic report. And so I think definitely HSMD, with its depth of information on somatic cancer variants and used along with a well-established database like HGMD for germline variants, could really help a genetic counselor or a variant analyst separate the true somatic VUSs from germline variants that may actually have significance in a germline context, but not be considered significant in a somatic context. So I think we're in this age where the complexity and the abundance of information that we have to work with on an everyday basis has necessitated this better collaboration and the use of multiple resources, multiple tools to help make your job easier, to help perform variant interpretation with high accuracy and confidence. So I think that is where I am going to transition to showing you some more examples on HSMD.
Let's dive in.
Yeah. Hold on. Let me share my screen. All right, so let's look at a few alterations. This is the Alteration Explorer, where you can search, sort, and filter to look for alterations of interest. And what shall we look at? Okay, Chelsea, since you mentioned Lynch syndrome, since you were talking about Lynch syndrome, let's look at a variant in a mismatch repair gene, MLH1. As you can see here, it has pulled up two different entries, variants that result in the same protein change, but have a different change at the coding level. So this one is clearly the one that has been reported more frequently in the literature. So let's click on that. It'll take us to the alteration page, and here you have this nice summary telling you about basically the significance of this alteration. So it has been reported as a germline SNP, has high allele frequency in the general population. And in functional studies, it was reported to result in activity similar to wild-type MLH1. And further, our scientist has also looked at ClinVar to verify that based on the most recent submissions, it had a likely benign classification. And so this was the date here should tell you when our scientists last reviewed the interpretation for this variant. And based on that, it has a predicted no effect or normal functional impact and an actionability of tier 4. And then, I did want to talk about how there are links to HGMD and ClinVar and dbSNP on here, like we just talked about. Okay. Yeah, if you click on that, it'll take you to HGMD, and as you can see, HGMD has assessed this one as a disease-associated polymorphism. And you can also access information from databases in a different way, because the QIAGEN KB incorporates data from some databases as well. What you could do here is go to the bibliography and filter by the category database import, and now you see that there are multiple findings extracted from ClinVar, Cosmic, HGMD, and so on. In addition to MLH1 and other mismatch repair genes, HSMD has extensive coverage for genes involved in homologous recombination repair, like BRCA2, BRCA1, and others. Let's look at some examples in ATM. Okay. All right. So let's click on this. This particular mutation from the Alteration Explorer, you can see that it's a VUS, and it's been classified as tier 3. Going to the alteration page, you have a nice summary similar to what I showed you before for the MLH1 variant, and the conclusion is that the effect of this mutation is unclear at this time. So it's a VUS, and you can be confident knowing that it has been reviewed by scientists as recently as April 2022. That's a good example. And what else? Okay, how about this one? Yeah. So this one is the well-known mutation, ATM R3008C. It has been reported to result in a loss of ATM kinase activity. It is known inactivating. It has been assessed as tier 1, and it has been reported in a germline context as well. So this mutation can be germline, but from the bibliography, let's look at the database import. It has also been reported in Cosmic, so it can be observed in both the somatic and germline context, and you can use HSMD to not only get a very useful summary of the clinical significance of a particular variant in cancer, but it can also sometimes point you to a potential germline origin. And you can use valuable resources like GMD to move to the next steps of your process. Okay, so I can probably spend all day talking about HSMD and showing you more examples, but I know that we are short on time, so I will now conclude and move on to the trial details. So you can sign up for a 5-day free trial of HSMD. Here's the link, so check it out and let us know what you think.
All right, and it looks like we are ready for the Q&A segment of this session. If you haven't already, please submit your questions now. Again, any questions that we don't get to, we will answer via email, the one you provided at registration. All right, Chelsea, Aarthi, the first question that we have today. Ooh, this one's an interesting one. Chelsea, this one's for you specifically. What do you like about the platform?
Oh, that's a good question. I like a lot of the things about the platform and the fact that everything's right there in one fell swoop. I really like the fact that it links out to guideline and kind of have that other information. But one thing that my head went to is because I did spend some time in policy and prior authorization is really where my head went. Is it potentially be helpful in writing letters of medical necessity or making an appeal information for a patient related to medical management changes for a patient. I found those particularly challenging in my previous courses of work. And so having that as a resource is where my head went and something that I think is really helpful about the platform.
Okay, second question. How often is HSMD updated?
I'll take that one. Currently, HSMD is updated every quarter. So once in 3 months. With each update, we add a whole lot of new variants and recently opened clinical trials, recently approved drugs. On average, we add about 15,000 new clinically observed variants with each release.
Is this data available in GR38? Is this data set available as a download?
Great questions. Currently, the data in HSMD is in GRCH 37, HG19. We are planning to enable GRCH 38 as well, and so that's in the works. Currently, the data in HSMD is not available as a download, but we do have an API version that you can use to integrate HSMD into your analysis pipeline.
Okay, next question. Does HSMD include fusions or CNVs?
Yeah, HSMD does include fusions and CNVs. In fact, it was part of our most recent release, and we're going to keep building on our fusion and CNV coverage in HSMD.
All right, and with that, unfortunately, we've been having a lot of fun, but it looks like our time together is up. Again, if you'd like to learn more about HSMD, please visit our website at digitalinsights.qiagen.com/explore/HSMD. Ms. Alexander, Dr. Goverdhan, thank you so much for your time today. I'd also like to thank the audience for joining us today and for their interesting questions. Please note that the webcast can be viewed on demand. LabRoots will alert you via email as soon as it's available for replay. We encourage you to share that with all of your colleagues who may have missed today's event. And until next time, take care, everyone. Goodbye.
Thanks, bye.
Thank you, bye.